Okay, so this is just a quick little review of yesterday's notes and then kind of to explain what you're going to be doing today for today's activity. So this whole unit is basically just kind of talking about how energy is conserved. We're still talking about that law of conservation of energy. It's just like, again, all of our other conservation laws. Energy can never be destroyed or created. Okay, it can only be transformed. So all of the energy that's in the world is going to be all the energy that's in the world. We can't create more energy, right? We just have to transform it. So that's kind of the whole, basically, if you think about, well, electricity and power and the whole argument of how we can get natural resources to give us electricity rather than using oil and coal, right? If we're using solar energy, we're just transforming that energy from the sun into electricity. Okay, we can't create electricity from nothing. We have to get that energy from somewhere, whether it's oil or solar or nuclear energy, like we talked back when we talked about Chernobyl and nuclear reactors. So energy is just the ability to do work. In order to do anything, you need energy. Just think about you. If you don't eat for a day, you're tired and lazy and lethargic because you can't do anything. Your body needs energy in order to move around and to function and to do all of its daily functions. So we have two basic forms of energy. We have potential. Okay, this is stored energy. It depends on position and shape. So if I look here at my two little skiers, one skier is way up here. The other skier is way down here. Okay, this guy has more potential energy because he's higher up. Okay, so that's where I get this depends on my position. The higher an object is, the more potential energy. Okay, kinetic energy is, again, the energy of moving object. We've kind of talked about that when we talked about momentum. The faster something's moving, the more kinetic energy it's going to have. So since I can't just get energy from nowhere, if I think about my two skiers here, which one do you think is going to be going faster when you get to the bottom of the hill? Well, if you guess the blue one, you would be correct, right? He's going to be going fastest because he has more potential energy at the beginning. So at the end, he's going to have more kinetic energy. Okay, he has more energy at the beginning to convert into speed. Whereas this guy, my yellow guy, he's not going to be going quite as fast because he doesn't start out with enough energy to go as fast as the blue guy. Okay. So again, here's just the definition. Energy cannot be created or destroyed. It can only be transformed. Okay, so we have like an example, lighting a match. Okay. There's a couple different transformations here that to start with. Okay, so at the beginning, just that movement, when I'm striking a match, right, what am I actually doing? Well, there's this stored chemical energy inside the match. There's some kind of chemical in the match that's going to burn. Okay, so when that happens, when it burns, that chemical energy is actually transformed into two different types, into heat and into light. So here's just a list of some potential energies. You'll need to kind of see these, look at these when you're doing the worksheet for today. So basically all of these energies, the reason they're called potential is because they're all stored in some way. Okay, if I think about chemical energy, we have like food, right? Food is stored energy. You eat it, it stays inside your body. It gives you that energy for when you need it. It's stored there. A battery, right? A lot of times we call those lithium ion batteries. Okay, that's an energy, chemical energy. It's an element, right? It's stored inside the battery for when you need to use it. Okay, elastic energy is stored in something that's been stretched. So if you think about like a bow and arrow, right? The reason your bow and arrow can move super fast and make it to the target is because you stretch that string, that band, elastic band back really far and then let go. If I only stretch it back a little ways, the arrow is just going to fall to the ground. It's not going to have enough of that stored energy to convert into kinetic energy. Gravitational just has to do with how high you are. So that's kind of like the two skiers example. The higher off the ground, the more gravitational energy you have. And then we've talked about nuclear energy before. That's just those energy that's stored within the nucleus of the atom. So we can either have fission or fusion. Somehow we're separating or combining those atoms to create energy. And that's like those nuclear power plants that we talked about. For kinetic energy, okay, we have one, you can think of it as melts, if that helps you remember the names of these, or you can just refer to this chart. But mechanical is kind of where we're getting all that basic motion. Like if I go for a run, okay, then that's mechanical energy. Okay, it's a type of kinetic energy, but I'm moving, it's a moving object. My bicycle tire, if I'm riding my bike, that's mechanical energy. Okay, the bicycle wheels are moving, they have kinetic energy, okay, it's moving, that's mechanical. That's kind of like the catch-all. If you can't think of where something falls, it's probably in that mechanical category. Electrical is just what you're thinking, it's electricity. Okay, so any kind of electricity. Remember, if you think electricity flows from one place to another, right? It comes down power lines, it goes through the charger, the cord in your charging, in your phone charger. So it's moving, so it's kinetic. Same thing with light and heat. They're both kinetic energy. They both move towards us, right? And then sound, okay? All of those last three, those are all like energy waves, right? We think of those as like a wave that's moving towards us. Okay, sound waves, thermal, heat waves, light waves. Okay, we see all that because it's kind of moving towards our eyes. So what you're going to do for today's activity, there's just a few little examples of different ways in our world that energy is transformed. Okay, so you're going to kind of just name, fill in the chart by naming the different types of energies that is present. So you're going to be using these last two charts here to kind of help you. And like I said, I'll post this, the actual slides also too, so you can just pull up the